Hi students, welcome to the session on mutual inductance. Right, so already we know that what is inductance. It is resistance to the change of current, right? Resistance to the time varying current. Now we see and we studied about self inductance. It is what resistance to the uh, time varying current which is passing through a same circuit, right? So now we will see what is the mutual inductance. Mutual inductance is a phenomena. It's a phenomena, right? In which what happens is in which change of current in one coil causes or induces EMF into an another coil. EMF into an another coil. Whereas in self-inductance, it will induce EMF in the same coil. Hope you remember this equation. EMF is equal to minus L di by dt. The change of current causes induced EMF, but it is in the same coil. Whereas in mutual inductance, uh, it will induce EMF into another coil, which is placed within the same magnetic field, within the same magnetic field. That's what the difference between self-inductance and mutual inductance. Okay, let us see here. Right. So here we have two coils. This is one coil number 1. This is coil number 2. Here two coils are placed very closer. Right. When current flows through the coil it is a primary coil. Let us assume this primary coil. Current flows through this I1, and this is secondary coil. Current flow through that is I2. When the current flows through this coil, what will happen? It will produce a magnetic field, right? So this will produce magnetic field, and that magnetic field will interact with the secondary coil. So it will induce EMF in the secondary coil. Similarly, when current flows through the secondary coil, it will induce EMF in primary coil also, right? So what is mutual EMF or mutual inductance is the phenomenon of inducing EMF in one coil by the changing current in another coil, right? So that is what known as induced EMF. Sorry, mutual inductance, right? So it is mutual inductance. So when current flow in the one coil changes, it will induce a EMF in another coil, right? That phenomena is known as mutual inductance. Whereas self-inductance is, it will induce the EMF in the same coil, right? So now we derive the expression. We know that mutual inductance is given by M. The symbol for mutual inductance is M. M12. What is the meaning? This is the inductance in M1 caused by secondary coil. So inductance in primary coil caused by secondary. So that's what M12. That is given by lambda 12 by I. We know that L is equal to n pi by I, or L is equal to lambda by I. Hope you remember this equation. The same thing. M is equal to lambda by I, except this is the mutual inductance. Right? So what is the thing? Lambda 12 is nothing. Lambda is a flux linkage. So what is this? Flux from coil 2. Flux from coil 2 links with coil 1. That's what flux linkage, right? There in the same coil, so we don't put a symbol in a self-inductance, or simply it is, we can write lambda 11. or we can write lambda 2 2. Flux from secondary coil induces the links with the same coil. Here flux from coil 2 links with coil 1 divided by it is I1. Sorry, I2. Who is creating the flux in the coil 2? Current flowing in the coil 2 only can create. So current flowing in secondary. Who can create flux from coil 2? Current flowing in the secondary, that is I2. That's what mutual inductance. Okay, so mutual inductance on coil 1 from 2 is given by, what is flux? Lambda is equal to n pi, we know. So lambda is n pi. So pi is flux from secondary to primary coil. So 1 2 secondary to primary divided by I2, where inductance is induced in the first one. So it is N1. Okay, so that's what mutual inductance. So mutual inductance on coil 1 from 2 is given by N1 pi 1 2 divided by I2. Similarly, what will be M21? M21 is nothing but inductance in coil 2 produced by current flowing in coil 1, flux from coil 1. So it is flux from coil 1 is linking with the coil 2, because I want inductance in inductance in coil 2. So flux from coil 1 links with the coil 2. Who is producing flux from coil 1? I1, current in the coil 1. So I1, where it is produced in coil 2, because it is coil 2. So it is number of turns is N2. Right? This is what M12 and N2. Okay, so from this we understand. Okay, so we can say this is a mutual inductance, right? So flux linkage, we can define flux linkage as, flux linkage is given as N1 phi1 is equal to M12 I2. Why this M12 I2? That is equal to N1 phi1. That is what? M12 is mutual inductance between coil 1 and 2, and I2 is a current flowing through that coil 2 or secondary. So where it is producing? It is producing flux in the N1 primary coil and flux in the N1, right? That's what. Simply phi 1 2 I write as pi 1. Similarly, I can write M21 into I1. So M21 into I1, if you bring this side. So the mutual inductance is produced in secondary, because M21 is mutual inductance in secondary. So N2. So it is due to the flux linkage from 1. Right? So sorry, flux linkage from 2. Okay. Right? So this is what in simplified notation I can write like this. Okay. So you see what is that? For any equation, we know right hand side is cos, left hand side is effect. This is cos, this is effect. Who is producing flux? Lambda is equal to N5 flux linkage. Who is producing the flux linkage? Current. That's what we studied in self-inductance. So current produces flux linkage. That factor is given by N. If more turns, we have more flux linkage. That's what we studied. Since it is relating a current flowing through one conductor to the current flowing through the another, so it is given the notation of mutual inductance, not self-inductance. Okay, so that's what very important. So simply I can write from the above equation, M12 is equal to N1 phi 1 divided by I2. M21 is equal to N2 pi 2 divided by I1. Yes, now it is very simple to understand. You see why? You see that what is that? The flux in the coil 1 produced by coil 2. So what is that? The current flowing through that coil is the main reason for all. So I2. flux linkage. We know L is equal to N pi by I, right? So I is secondary current. I want to produce a flux in the first one, mutual inductance. It is linking second and first. So in first only it is linked, so it turns is N1 pi 1. Similarly, M21 is equal to N2 pi 2 produced by I1. Right? Simple shortcut. Right? So that's what we have to remember. Okay. This parameter is talking about denominator. This parameter is talking about numerator. In short way to remember. Right? So that's all about mutual inductance. If you have any doubt, please ask me in comment section. I will clarify all your doubt. Thank you.